we're going to solve assignment 4.2. In this case, is quadratic assignment. We're going to start with problem number 1. So remember that to graph, we need to determine if the function is in a standard form or vertex form. Then you're going to state the key facts being asked and graph the function. So for example, for problem number 1, what I'm going to start doing, and as you can see, I'm going to use a separate piece of paper to do all the steps. So I have y equals negative x squared plus 2x plus 1. Now what I'm going to do is, remember, I usually like to write 1 if I'm missing that number. So I have that the value of a is equals negative 1, the value of b is 2, this is a, okay, this is the value of a, and this is the value of b. We need to mention that this is a standard form of the quadratic function. It's a standard form because I have ax squared plus bx plus c. Now, remember the axis of symmetry formula that we had was x equals negative b over 2a. So we know that b is 2. So I have negative 2 over 2 times a, which is negative 1. So I have negative 2 over 2 times negative 1 is negative 2. And we know that negative 2 divided by negative 2 is equals to 1. So my axis of symmetry is equals to 1. And let's mention this one, okay, x equals 1. What is the axis of symmetry? It's where your parabola is going to be split into 2 equal parts. So if I graph that axis of symmetry, I go to 1 here, and I'm going to use this green marker, green pen, and I'm going to draw a dotted line that's my axis of symmetry. That will be the first step that I will do. Mark the axis of symmetry at x equals to 1. Now what is the next point is to find the y value to get the vertex, because they want me to know, okay, here axis of symmetry x equals to 1. What is the vertex? So I need to know, remember that the vertex was hk. So I know my value of h, in this case is 1. H is the same value as x. So I have 1. So now I need to know my k, or the y value. So to find the y value, I need to plug in that 1 into my original equation. So I can do y equals to negative 1. And you can just open parentheses and says 1 to the second power plus 2 times 1 plus 1. Okay, we know that 1 to the second power is 1. So 1 times negative 1 is negative 1 plus 2 times 1 is 2 plus 1. Now I have negative 1, I have 1, they cancel out. 1 minus 1 is 0, so y is equals to 2. So in this case, 1 comma 2, and I can box this one for you to know. So now I know my vertex is 1 comma 2. That means that function moves 1 unit to the right and 2 units up. Now what they want the vertex form. The vertex form, remember, in this case was y equals a x minus h squared plus k. We know a is negative 1, right? So I have a equals to negative 1. If you want to write 1, write 1. I have x minus h. What is the value of h? In the vertex is 1, so minus 1 square plus k, which is plus 2. That's the vertex form. Another way to write the vertex form is just y equals negative x minus 1 to the second power plus 2. You can write the negative 1 or just leave negative in front of the parentheses and it's the same. So in this case, vertex form is y equals negative x minus 1 to the second power plus 2. Okay, what else? Do I have a minimum or do I have a maximum? Let's see the parabola. So I'm just going to sketch something here. I know the a value, the initial coefficient, the leading coefficient is negative. That means that parabola opens down. That parabola is going to opens down. So I have a maximum value. So I have a maximum value. Okay. And that value happens in your y value of the vertex. So the value is y equals 2. Now it says root zeros, x-intercepts, and solutions. I'm not going to ask you to do those ones because we haven't go over factorization. I'm going to just, if you can see where the graph crosses the x-axis, that's going to be your zero, and you're going to see that one. So remember that we graph using the rate of change. We have 1, 3, and 5. So in this case, if I'm going to write the vertex is 1 and 2. Write 1 and up 2, and I'm going down. The parabola is going to opens down. So I have down 1, right 1, down 1, left 1. Then also I have down 3, 1, 2, 3, right 2, left 2. See, the axis of symmetry is helping me to determine where the point is going. Now I'm going 5 units down. 1, 2, 3, 4, 5. 1, 2, 3. And then 1, 2, 3 to the left. So that's my parabola. Now you just need to get those points together. Okay, and this one's the same. That's my first parabola. Okay, remember we have a vertex that is 1, 2. What is the roots? The x-intercepts. The x-intercepts in this case are the numbers where the graph crosses the x-axis, and in this case is not an exact number, it's going to be an approximation. So I'm going to say this one is between 2 and 3, so I'm going to have 2.5, and this one is between negative 1 and 0, so negative 0.5 and 2.5. But I don't want you to stress out about those points. It's only if they are really obvious at this point, just write that solution. If not, just leave it blank and it will be fine for this assignment. Let's go to problem number 2. Problem number 2, I think, because it's vertex form, it doesn't have that many steps as problem number 1. So in this case, what is the vertex? Remember that the vertex is the opposite of this number. Remember, we do x minus 3 equals to 0, so x is equals to 3. And this number remains the same. So my vertex is 3, 1. 3, 1 is my vertex. What is the axis of symmetry? The axis of symmetry is the value of x in your vertex. So x equals to 3. Let's answer this one. It's a standard form or vertex form. We can see that it's a vertex form. So I circle that one. Does the parabola opens up or opens down? The leading coefficient here is 1, so it's positive. So if it's positive, the parabola opens up. So I have a minimum value. So I have opens up, and we have a minimum value. Where that value happens, happens at y. We go to the vertex, we look at the y equals 1. Okay, what is the y-intercept? To find the y-intercept, we're going to make x equals to 0. So look at this one. Let's do it this way. Y equals to 0 minus 3 to the second power plus 1. So we make x equals to 0. So 0 minus 3 is negative 3 to the second power plus 1. Negative 3 to the second power is negative 3 times negative 3 equals to 9. So I have 9 plus 1 equals to 10. So my y-intercept is 0, 10. Do I have root zeros and x-intercepts? Let's see. Let's graph. Okay, let me draw the axis of symmetry. The axis of symmetry is x equals 3. So at 3, I'm going to draw a line. I'm going to draw a vertical line. That's my axis of symmetry. Okay, and now my vertex is 3 and 1. 3 in x, 1 in y. This point here, that's my vertex. My rate of change is 1, 3, and 5. I know it opens up, so that means I'm going up. So I go up 1, right 1, up 1, left 1. Then I go 3. 1, 2, 3, right 2, left 2. Then I go 1 here. 1, 2, 3, 4, 5. 1, 2, 3. And 1, 2, 3. See, it goes straight to my y-intercept 10. So we go and we now graph the parabola. Okay, let's do the other side too. So I'm going to do my x-intercepts. Can we see that the graph does not cross the x-axis? So we're going to call this one imaginary solution. We don't have x-intercept because the graph goes up. It does not touch the x-axis, so we have imaginary solution. So that's the solution for problem number 2. Let's go over problem number 3. In this case, we have it here. Let me move the camera. We have problem number 3. We can see again that is a vertex form. So we have vertex form. The value of a, I'm going to write here, a is 1/2. Is positive. That means the parabola opens up. So the vertex is the opposite of this number. So I have 4, negative 2. So 4, negative 2. This number remains the same. What is the axis of symmetry? Is the value of 4. So it's x equals to 4. Opens up. We mentioned that if the value of a is positive, opens up. So if it opens up, we have a minimum value. We have a minimum value. What value is that one? Here, minimum. What value is that one? Y equals negative 2. What is the y-intercept? We can make x equals to 0. So let's try that one. Let's see. So I have y equals 1/2 0 minus 4 to the second power minus 2. Now what I'm going to do is equals to 1/2. 0 minus 4 is negative 4 to the second power minus 2. Negative 4 times negative 4 is equals to positive 16. So it's equals to 1/2 times 16 minus 2. 16 times 1/2 is 8. Okay, so we have 8 minus 2. Y equals to 6. That's my y-intercept. So we have 0, 6. Now, let's see the x-intercept, if we have x-intercept. So I'm going to draw my axis of symmetry, which is x equals to 4. So I go to x equals to 4. And I'm going to draw an imaginary line. That reason why is dash 4. Then I go down 2 units. So I go 1, 2, down 2 units. I know it's going to open up, and I'm going to have a minimum value. The y-intercept is y equals to 6. So I go 6 and I make a point here. Now remember that your axis of symmetry is where the graph splits in half. So I count 1, 2, 3, 4, 1, 2, 3, 4. So I'm going to have the same distance to the other side. Now I need to figure out the other points. Remember that your rate of change is 1, 3, and 5. So in this case, we multiply by 1/2 times 1/2 times 1/2. And this one is equals to 0.5. I'm not going to leave the fraction. I'm going to use decimal. 0.5 equals 1.5 because it's 3 over 2 equals to 1.5 equals to 2.5. Okay, knowing that it opens up, I'm going up, in this case, half unit, and then I'm going 1 to the right, 1 to the left. From this point, I go 1.5. So I'm going to use this 0.5 here, and then I'm going up 1, right 2, up 1, 0.5, left 2. So I have my x-intercepts. In this case, are going to be 2 and 6. 2 and 6. That's where the graph is going to cross the y-axis. Now I have 2.5. So I have 2 units, 1, 2, then 0.5, then 1, 2, 3, and 1, 2, 3. And now I'm just going to graph my parabola. Oops. Right there. And I do the same to the other side. Okay, it's not going to be perfect, but it's going. There you go. That's it. So that's your parabola. Now let's do number 4. Number 4 is another that is in a standard form. Standard form. See, 2x squared minus 16x plus 33. I'm going to use the paper again, and I'm going just to turn around. It's the same paper that I was using, so I'm just going to turn around here. So what I have is y equals, and I have 2x squared minus 16x plus 33. I need the value of a, so I have a equals to 2. This is a. This is b. So b equals to negative 16. Now I need to know my axis of symmetry. X equals to negative b over 2a, which is the same as having negative 16. See, negative b is negative 16. So I have 2 consecutive negatives, then over 2 times a, which is 2. I have 2 consecutive negative, make it positive, so I have 16 over 4. Okay, so 16 divided by 4 is equals to 4. So my axis of symmetry is x equals to 4. Now what I need, the value of y of my vertex. So I come to my original function, y equals to 2x squared minus 16x plus 33. And I know this one is 2 times 4 squared minus 16 times 4 plus 33. 4 to the second power is 16. So I have 2 times 16 minus 16 times 4 is 64 plus 33. 2 times 16 is 32. 32 minus 64 plus 33. If we put all this one in the calculator, I have 33 plus 34 is 65, and 65 minus 64 is equals to 1. Y equals to 1. So my vertex is 4, 1. So I go, what is the axis of symmetry? We have x equals to 4. X equals to 4. What is my vertex? Is 4, 1. What is the vertex form? Remember, let's do it here in this piece of paper. So I have y equals a x minus h squared plus k. I know a is 2. So y equals 2, parentheses, x minus, I know h is 4, x minus 4 squared plus 1. So this will be my vertex form. So my vertex form is 2y equals to 2x minus 4 squared plus 1. Okay, we're done with that one. Now do we have a minimum or do we have a maximum? My value of a is positive, so the parabola opens up. So my parabola opens up. So I have a minimum value, because if you graph a parabola that opens up, it goes this way, and we have a minimum value. Which value is that one? Remember again, that value is going to be your value of y equals to 1 is the h part of the vertex. Do I have x-intercepts? Do I have roots, as we call it? Let's draw the axis of symmetry. So I have an axis of symmetry of 4. So I go to 4 and draw this line, imaginary dotted line. Okay, that's my axis of symmetry. My vertex is 4 and 1. So I go 4 units to the right, 1 unit up. We mentioned that opens up. My rate of change is 1, 3, and 5, but my value of a is 2. So times 2 times 2 times 2 equals to 10, 6, and 2. So I go up 2 units, right 1, up 2 unit, left 1. Then I'm going 6 units up. 1, 2, 3, 4, 5, 6, 1, 2, and 1, 2 to the left. I'm not see that this graph crosses the x-axis, so I have imaginary solution. Imaginary solutions. Now you graph. And the same to the other side. Okay, so that's the solution to that part. Let's see if I can do one more from the other side of the paper, and I think everything is just exactly the same. As you can see, it's exactly the same, so you're going to give it a try to this one. The only difference is just domain and range that we have there. Remember that if they ask you for domain, you have from negative infinity to positive infinity. That's your domain. And range, when you find the vertex, let me do this one because this vertex is negative 2, 1. The value of a is negative, so the parabola opens down. Okay, so that means you're going to have a range from negative infinity, because we count from negative numbers. We see that the graph is going all the way down, so from negative infinity to 1, which is your maximum value. That's where the graph gets to the top. So you're going to find the axis of symmetry, then your vertex. So remember that your range, I know this parabola opens down, see, opens down because the value of a is negative. So we're going to have a range from negative infinity. I did this one, so you're going to control this section of the page. So I know the other part is just 2, 1. And then you graph the function. So if you have any questions, please leave it in the comments, or you ask, and I will be able to help. Have a good day.